Hello everyone. Hello everyone. Um, Welcome to Deborah's YouTube channel. I am Daniel, and today we are diving deep into Amazon Web Services, specifically Virtual Private Cloud, or we can call it as a VPC. If you are new here, don't forget to hit that subscribe button and ring the notification bell so you will never miss any of our AWS and cloud related content. Let's get started. So the title, you might be, seeing in that in the thumbnail itself. It's AWS VPC, building a secure and then isolated in the network in the cloud. So what is VPC? Exp so in this entire video, what we are seeing is, what is VPC and what are the key benefits of VPC, scalability, control, security, and so on. And then know what are all the components of the VPC. So the components are subnets, route tables, internet gateway, network access control list. We can call it as a NACL, and then security groups, SG, virtual private gateway, VPN, and then we have a direct connect. And then we are going to see about how to create the AWS VPC in the AWS Management Console. Okay, we will show that how the subnet works, and then how to create the route tables, and then how to create the gateways, and so on. Security in the AWS VPC. We are going to discuss about the security groups and then NACLs for controlling the inbound and then outbound traffic. Explain how to set up the network ACL rules and so on. Connectivity options. There are many connectivity options. So we are going to see that how to connect your AWS VPC to internet using internet gateway. Discuss the options to connecting on-premises data center through the VPN or the direct connect actually. So how we are going to talk to internet gateway, and we are going to talk about on-premises data center. Now, VP, and then we will see about what is VPC pairing, describe the VPC pairing and its use cases. We will show that how to set up the VPC pairing in the AWS console as well. Some of the best practices, share some of the best practices, designing and then managing the VPCs. And we are going to emphasize the security, scalability, and then cost optimization. It's a little costly, right? And it has more secure features. We will go and see that. First, what is VPC? AWS VPC. Amazon Private Cloud is a key network service provided by Amazon Web Services that allows user to create and manage the private isolated network environment within the AWS cloud. So within the AWS cloud, we can create the network service. So we are going to isolate our network. So that's our primary goal of creating the VPC. It enables users to launch AWS resources such as EC2 instances in a virtual network that closely resembles a traditional on-premises network setup. So what is the primary purpose of VPC? We are going to launch resources within this within this VPC actually, the private network setup actually. And AWS VPC is a fundamental building block for designing and then deploying the cloud-based applications. So we are going to create a cloud-based application. It provides the network isolation and control necessary to create secure, scalable, and then highly available architecture in AWS cloud. Users can configure and then customize their VPCs to meet specific network requirement, making it a versatile and powerful services within the AWS ecosystem. So, it provides the network isolation and control the necessary to create the secure and then scalable high-level architecture, actually, highly available architecture, basically. So, we will see one by one. Okay. What is the importance of network isolation and security in the cloud computing? Network isolation and then security are paramount important in cloud computing due to the following key reasons. The first reason is data protection and then privacy. The second reason is compliance requirement. The third reason is preventing the data leak. Fourth one is protecting the intellectual property. Fifth one is minimizing the attack surface. Sixth one is resource isolation. Seventh one is security incident containment. And then eighth one is redundancy and then failover. Ninth one security auditing and then monitoring. DevOps and then microservices, scalability and performance, distributed workforce. Okay. What is data protection and then privacy? Network isolation ensures that sensitive data remains isolated from other tenants or unauthorized users in a multi-tenant environment. Properly security measures such as encryption and then access controls safeguard the data from unauthorized access or the breaches. So data protection and then privacy means sensitive data remains isolated. Okay, so what are the sense whenever we have any sensitive data we will isolate them in a particular place actually. Also encrypt we will use encryption and then access controls who can access it, no, those kind of setup we will do it. The primary reason is safeguard the data from the unauthorized access or the breaches. Compliance requirements. Many industries and then regulatory bodies, say for example HIPAA and then GDPR, have stringent data protection and then privacy regulations. Network isolation and then security helps organization meet these compliance requirements. So yeah, whenever we go with the AWS VPC, it has regulatory bodies like HIPAA and then GDPR. It follows the compliance requirements actually. That's preventing data leaks. Effective network isolation prevents the data leakages and inadvertent exposure of sensitive information to unauthorized users or external threats. So, like it prevents the data leak. Okay, so unauthorized users or the external threats will not be happen. Protecting the intellectual property IP. Companies வந்து rely on the security of their IP, right? So the network isolation safeguards the against IP theft actually, and minimizing the attack surfaces. All well-designed network isolation strategy reduce the attack surface by limiting access points and potential vulnerabilities that attacks can explicit. Okay, so it is limiting the access points and then potential vulnerabilities. And then what is the resource isolation? Resource isolation prevents one customer workload or application from negatively impacting the performance or the security of others in the shared cloud environment. So when we create the shared cloud environment, the performance and then the security, you know, will be isolated and it will not be impact. Security incident containment. Network isolation helps contain the security incidents. Yes, there is a security incidents. If one part of the network is compromised, it minimizes the risk of lateral movement to other areas. If one part of the security is compromised, then the other portion will be protected. Actually, that's the security incident containment. And redundancy and then failover. Cloud provides often offer network redundancy and then failover options to ensure highly availability. These features rely on network isolation to maintain the services continuity. So whenever the failover happen, it takes another resource and then it will continue the service actually. So that's the primary motto of redundancy and then failover, network redundancy and then failover options to ensure the highly availability. That's the point. Security auditing and then monitoring. Isolated network facilitate effective monitoring and then auditing of network traffic, making it easier to detect and then respond to security threats actually. So that auditing and then monitoring is easier to detect the respond. DevOps and then microservices. Modern cloud native applications often use microservices architecture, where network isolation helps maintain separation between microservices for security and scalability. Um, Scalability and then performance. Effective network isolation allows for granular resources allocation, and the scaling ensures that workload have the required network resources without interference from others actually. So granular resource allocation and then scaling policy, we can implement actually. And then distributed workforces. We know that no VPC it is a distributed workforce, right? So within the with the rise of remote work, network security is critical to protect the data as it traverses various networks and endpoints. In summary, network isolation and then security are essential aspect of cloud computing to protect the data, meet the compliance requirement, prevent the breaches, maintain the integrity and performance of cloud-based systems. Implementing robust security practices and leveraging cloud native security features are vital steps in securing cloud environments. Second, we are going to explain the concept of virtual private cloud (VPC) and describe how it has a private and isolated network environment within the AWS. Okay, how it is isolated. We'll see. A virtual private cloud is a virtual network environment within the Amazon Web Services that allows you to create the logically isolated section of the AWS cloud where you can launch and manage the AWS resources. It serves as your private customizable network in cloud and provide a range of benefits for building and managing your applications and services. Here are the key benefits of VPC. So we can, create a virtual or logically isolated section where we can launch our and where we can launch or we can manage our AWS resources. That's the primary motto of the VPC. Logical isolation. What does it mean? A VPC is logically isolated from other VPCs and broader internet, providing a secure and then segregated environment for your resources. You have complete control over the IP address range. We can call it as a CADR block and create subnets within the VPC to further segment resources. Yeah, and so we can logically isolate from other VPCs and broader internet, providing a secure and then segregated environment. That's all. Customizable network topology. You have flexibility to design your VPC network topology, including the creation of multiple subnets, route table, and then security groups. This allows you tailor the network match your specific requirements and then security policies. So, flexibility to design your VPC network topology. That's all. Within that, multiple subnets, route tables, security groups will be there. Actually, that's all. Resource deployment. You can launch a wide range of AWS resources within the VPC, including the Elastic Cloud Compute EC2 instances, RDS, Lambda function, and so on. These resources are placed within the subnet you define. So within the subnets, actually, we can place all these resources. That's the primary benefit of VPC. Controlled access. You can control the inbound and then outbound network traffic to find and from your resources using the security group and network access control list. These allows you to specify who can access your resources and which port and which protocols can able to access. So controlled access. Who can access the resources that we can able to define it through NACL. And then connectivity options. VPC can be connected to the internet through an internet gateway. So the VPC can connect to the internet gateway. Ideally, the VPC, not designed for to connect with an internet gateway, internet, but if the VPC inside there is a subnets, if requires, to communicate with the outside of the world, then we can provide the internet access. That's what they are saying here. In public subnets to communicate with the internet, you can also establish the private connections such as VPN. Or AWS Direct Connect to link your VPC with other on-premises data centers or other networks securely. Okay. So public subnets to communicate with the network, that is the first point, and VPC within on-premises data center. VPC want to connect with an on-premises data center, we can use the um, VPN direct connect actually, right? And then scalability. VPC can now span multiple availability zone within an AWS region, enabling you to design a highly available and fault-tolerant architectures. You can add or remove the resources as needed to accommodate the change in the traffic and then demand. So, it spans multiple availability zone, okay, within the AWS region, and enabling you to highly available fault-tolerant architecture actually, right? That's the primary motto of the VPC. Security and then compliance. VPC provides a fundamental layer for security and compliance in the AWS. You can enforce the security policies, encryption, and then access controls to meet your organization's security requirements and regulatory standard. So it enforces the security policies, encryption, and access controls. That's the primary advantages of VPC. And then monitoring and then logging. AWS offers monitoring tools like the VPC flow logs that captures the information about the traffic within your VPC. So it will show us what is the traffic. This data can be used for troubleshooting and then security analysis and compliance auditing. So it used for troubleshooting, security analysis, and then compliance auditing and so on. Okay, what is global reach? VPC are not limited to single region, right? So in the earlier also we saw that it span multiple availability zones, right? So you can create the VPC pairing connections to connect VPC across the region, providing a global reach for your network architecture. Okay. Now we are going to see what is high performance, feature that is provided by the VPC, right? So AWS continually invest in its network infrastructure to provide the low latency, high bandwidth connection between the resources in VPC and external services. That's the primary goal, right? So low latency but high bandwidth connection that will connect with your VPC resources and the external services. Yeah. In summary, the VPC virtual private cloud is a cornerstone of AWS cloud infrastructure, offering a private, customizable, and secure network environment where you can deploy and manage your cloud resources. It allows you to extend your on-premises network into cloud while providing control, scalability, and security features to support your applications and services. So the third one, discuss about that advantages of using the AWS VPC. We saw that already. What are the features that are enabling by the VPC? But we are going to see a little more advantages, right? Um, like earlier we saw that it gives the scalability, and it allows us to set up the control, and it enabling the security features, and then these are the features it is enabling, correct? So emphasize, and also we are going to emphasize the flexibility to create the custom that creating the network topology. It is very matter of matter of minute actually. Amazon Virtual Private Cloud offers several advantages, including scalability, control, security, and flexibility to create the custom network topologies. These advantages makes AWS VPC a powerful tool for building and managing the cloud-based infrastructure. Here are a closer look at each of these benefits. First benefit. Scalability, elasticity. VPC are designed to scale with your AWS resources. You can easily add or remove instances and services to accommodate the changes in traffic and then demand. So easily we can add or remove the instances and the services, right? Next, auto scaling. VPC seamlessly, integrates with AWS auto scaling, allowing your application to automatically adjust its capacity based on the defined criteria. So auto scaling, automatically it adjusts the capacity. That's all. And then availability zones. VPC can span multiple availability zones within an AWS region, providing redundancy and then fault tolerance for your applications. This scalability ensures high availability. When we increase the scalability, highly it will be available. That's why. And the VPC provides, span the multiple availability zones. That's the point. VPC can span multiple availability zones. Okay. Now, network topology. One of the key advantages of AWS VPC is the ability to design your custom network topology. You can create the subnets, you can create the route tables, and then you can create the security group to match your specific requirements. So in the network topology, what are the components like, subnet, route table, security group, all these, topologies, network topologies, we can create in a matter of minute actually. That's all. Resource isolation. VPC allows you to isolate the resources logically and control the inbound and then outbound traffic with security group and the network access control list. So, resource isolation. How we are isolating it? We are logically separating it out, and then we are logically separating it out or isolating it out, and then we are creating the controlled inbound and then outbound traffic with the help of security group and network access control list NACL. Okay, what is access control? AWS Identity and then Access Management IAM provides fine-grained control to over who can access your VPC resources, ensuring that only authorized users and then services can interact with your infrastructure. So authorized persons can only able to interact with the infrastructure. That is the primary goal of access control IAM. And a security isolation, VPC are inherently isolated from each other and from the public internet. This isolation provides a secure environment for your resources. So it gives the secure environment for our resources. Security group. So, AWS VPC employ the security group acting as a virtual firewall. So, security means it is a firewall, virtual firewall that control the traffic between the instances. You can define the rules that allow and deny the specific traffic type. Traffic type. So, based on the traffic type, we can either to allow the access or we can deny the access. Actually, that's the advantages of security group actually. So the N, what is the okay, we have one more feature, network access control list NACL. NACL add an additional layer of security at the subnet level. So the first one is virtual firewall. The second one is additional security at the subnet level. We can define the rules inbound and then outbound traffic and so on. Okay, and encryption. VPC resources can use the encryption in transit and REST to secure the data. So basically, encryption, that's TLS and then SSL certificates, and then using the key management service KMS. They are using the KMS actually for the encryption, and then the flexibility to create the custom network topology. What are the custom network topology we will see? Okay, this is just a topology, network topology. Now we will see the custom network topologies, right? Subnet segmentation. VPC support the creation of multiple subnets, each within the own CIDR block. This allows you to segment the resources and control the traffic. It creates its own CIDR block. That does mean that no, from which IP address to which IP address, can able to access it, or the IP range we can call it as, right? That we can create it in the subnet segmentation. Route table. Custom route tables enables you to specify the traffic is routed within your VPC. You can define the different routing path for the subnets based on your requirements. Say, for example, how traffic is routed within your VPC. So that we can define in the route table actually. So accordingly, it will be route the traffic actually. What is internet gateway? Okay. While VPC are private by default, okay, we know that no, we all know that the VPC means virtual private cloud network, right? It's a private by default. You can attach an internet gateway to allow the specific subnet to access the internet when needed. So within the VPC, we will create the subnet. Within the subnet only, we will add the resources. My resource want to talk to outside of the world. In that case, what we will do? We will allow the subnet to talk to my internet gateway. Through that, we can talk to internet. That's the primary advantages of internet gateway. What is VPC peering? VPC peering lets you establish no private connection between VPCs. So now one or more two VPCs interconnecting each other, we can call it as a VPC peering. Even across the different, it could be across the different AWS accounts, creating the custom communication path. We can create the custom communication path actually. In summary, Amazon VPC provides the flexibility to design a custom network topology that meets your specific needs while offering the scalability, control, security. Whether you are building a simple web application or the complex application or multi-tiered application architecture, AWS VPC empowers you tailor your network infrastructure to your unique requirements, all while benefiting from robust AWS cloud platform. So it allows you to empower to tailor your network infrastructure. So entire network, no, we can able to tailor it. That is the potential benefit of the VPC. Now for an AB. Okay, what we are going to discuss here, the core components of the AWS VPC here are the core components and features of the AWS VPC. First, virtual network. AWS VPC allow you to create a virtual network in the cloud, complete with its own IP address range, CIDR block, subnet, and add routing tables. This network can be isolated from VPC and the public net. So we can create the IP CIDR block, subnet, and then routing table, and this network will be isolated from other VPCs or the public internet. What is subnet? Within the VPC, you can create one or more subnets. Yes, subnets are segment of a IP range of the VPC. This is the IP range of the VPC, are used to do group the resources based on the network requirement. So we can put the resources and we can allocate individual IP for it, and then we can able to access it. Subnets can be, public or private. The subnet either can it be the public or the private, depending on whether they are associated with a route to the internet. Based on the route, actually, internet. Okay. What is route table? Each VPC has its own one or more route tables that control the traffic routing within the VPC. So we will have a route table. The VPC will know controlled by this traffic routing. The traffic routing table. You can configure the custom route table to direct the traffic as needed. We can create custom route tables actually whenever we want. Internet gateway. This allows users within the VPC to connect the public internet. You can attach the internet gateway to the VPC. This enables the resources within the public subnet to have IP addresses and communicate with the external services. So whenever we are going to external services, internet or any other additional services or VPC, then we need a internet gateway. Okay. Okay, what is NAT gateway? What is the NAT gateway? We'll see. Okay, um, NAT gateway to allow the resources in the private subnet to access the internet while hidden from the public. You can set up a network address, a translation gateway, other instances. So normally the internet gateway for public subnet, right? If my private subnet want to talk to internet, yes, we can do it, but it's remaining the hidden from the public actually. You can set up the network address, translation gateway or instances. Private means it is a NAT gateway. Public means it should be the what internet gateway. That's all. And what is security group? AWS VPC includes the security group, which acts as a virtual firewall for your resources. You can define inbound and outbound rules to control the traffic to and from instances, actually. Network access control list. NACL are stateless network level security rules that allow or deny traffic at subnet level. NACL means subnet level. They provide an additional layer of security for your VPC. So it providing the additional layer of the security. Virtual private network VPN. AWS VPC supports IP section or segment VPN connections, which allow secure communication between VPC and then on-premises network. So when we will go to the VPN, secure communication between your VPC and on-premises network. What is direct connect? For dedicated high-speed connections to AWS, you can use AWS Direct Connect, which provide the private network connection between data centers and your VPC. Okay, if there is a data center that need to talk to the VPC, we'll go with Direct Connect. That's all. VPC pairing. VPC pairing enable you to connect the two VPCs to communicate each other as if they are on the same network. Okay, on the same network, when two VPCs are communicate with each other, then we are calling it as a VPC pairing. Okay, what are the steps creating the AWS VPC in the management console? Creating the AWS virtual private cloud involves several steps in the AWS management console. Here are a high level overview of the process. It is very simple by looking into the login into the AWS console and then creating it. I'm going to cover the theory part now. Later we will do the hands-on. Sign in into the AWS console. So go to the AWS management console, sign in into your account, open the VPC dashboard. Once logged in, navigate to the service drop-down menu, select VPC. Under the VPC networking and then content delivery section, this will open the VPC dashboard. Start creating the VPC. In the VPC dashboard, click the Create VPC button to initiate the VPC creation process. Configure the VPC basics. So in the Create VPC wizard, you will be prompted to provide the following information: network tag, IPv4 CADR block, IPv6 CADR block, configure DHC option, add tags, creating the VPC. Um, these are all the information it will ask. We'll see one by one. What is name tag? Give you your VPC name. And then IPv4 CADR block. Specify the IP address range for your VPC in the CADR range, CADR notation. CADR notation 0.0.0/16. And then IPv6 CADR block, it is an optional one. You can also specify the IPv6 CADR block if needed. Configure the DHCP options. This is also an optional one. You can choose the DHCP options or use the default settings provided by the AWS. DHC option control the DNS settings actually. Add tags. Additionally, this is also an optional one. You can you have an option to add the tags to your VPC for better resource organization and management. It tags name. It will provide some better resource organization. That's all. Creating the VPC. Review the configuration settings and then click on the VPC button to create the VPC. Once we done all the above steps, create the VPC. and then we can view the VPC. Once the VPC is created, you can view it detail in the VPC dashboard. Here you will find the information like whatever we provided, we pay VPC ID, IPv4, CADR block, status, and so on. Okay, and then we are going to create the subnet. Okay, create the subnet is an optional one. To use the VPC effectively, you may want to create the subnet. Okay, we need to create the subnet. Click the subnet within the VPC dashboard and then click the create subnet. Configure the subnet settings, including the CIDR block and then availability zone. And then configure the route tables and then routing. So this is also an optional one. You can create the custom route tables and associate them with your subnets to control how traffic is routed within your VPC. Navigate to route table in your VPC dashboard to set up the routing and create the ACL. Now this is important thing, an ACL and then security group. This is also an optional one, but if you set it up, it will good actually, right? It's a security feature. So to enhance the security within your VPC, you can configure the NACL list and security group. These provides granular inbound and then outbound traffics to your instances. So it controls the inbound and then outbound traffics. Create and then attach the internet gateway. This is also an optional one. If you want your VPC to have internet connectivity, you can create an internet gateway and attach to your VPC. This allows the resources within your public subnets to communicate with my internet actually. Create VPC pairing connection or direct connection. This is also an optional one. If you need to connect your VPC to your VPC or on-premises network, you can set up a pairing connections, or we can create the VPN connection actually. Now we are going to launch the resources. So our primary goal is we will create the VPC, we will create the subnet, and then we will create the network IP, we will create the routing table, and then we will add the NACL and then security group. Once after done that, what is the primary advantage? We are going to launch the resources, right? These are all security features that is enabled by the VPC. So within the VPC setup, you can launch AWS resources like EC2 instance, RDS, and more within the VPC. These resources can be associated with the specific subnets for the network isolation and then security. So this is, allowing the network isolation and then security. Please note that the steps mentioned above provided an overview of creating the basic AWS VPC. Depending on your specific requirement and network architecture, you may need to perform additional configuration and customization. Always consider best practices for network design and then security when creating your AWS. So this is a disclaimer. So just this is overview introduction. It may ask based on our requirement we can choose various options. Okay, now how to configure the subnet route table and then gateway in the AWS console. So far what we did is we created the VPC, we created the subnet, we created the routing table, we created the NACL, we created the security group. Now how to configure the subnet, how to configure the route table, how to configure the gateway in the AWS console. We'll see that. Configure subnets, route tables, and gateway in the AWS console involves several steps within the AWS Virtual Private Cloud services. Below, I'll guide you through the process. Sign in to your AWS console. This will be, a replica, the same how we need to, log into the console. Access VPC dashboard. From the dashboard console, navigate to the services drop down where you can select the VPC under the networking and then content delivery section. This will take you to the VPC dashboard and creating the subnet. This is also pretty simple. In the VPC dashboard, just click on the subnets, navigate to the left side pan, and where you can see that create subnet. Provide the subnet and then select the VPC you want to associate it with. Choose the availability zone. This is important. Okay. Define the IPv CIDR block for the subnet. Configure the other settings such as routing association and then security group settings. Click create button to create the subnet. That's all. So we need to associate it with the routing table, and then we need to associate it with the security group and other stuff actually. Now we are going to create the routing table. Okay. In the VPC dashboard, Click on the route table in the navigation pane on the left. Click on the create route table button. Provide a name for the route table and select the VPC you want to associate it with it, and create button, and then click on the create route table. That's all. So here also, can you see we need to associate that this route table, associated with which VPC, right? Here also we are associating that VPC and availability zone, and then we are associating that. Network routing tables association and security group. Okay. Now route table, configure the route table in the configure the routes in the route table. So now we are going to configure the route actually. Route table route is contained in the route table actually. Okay. Okay. Select the route table you created. We are going to select the route table. Click on the routes, edit the routes, add your routes based on your requirement. Say for example, enable the internet access for the subnet. So add the default route, this one pointing to the internet gateway. So my route will be pointed to a internet gateway. Save the changes. That's all. Now we are going to associate the subnet with the route table. In the association of the route table, click edit subnet association, and subnet you want to associate with the route table. Save your changes. That's all, and create an internet gateway. So now if it is if my public subnet going to talk to outside of the world through the internet, then we need a internet gateway. It is an optional one. If you want to create an internet access to the subnet, you can create the internet gateway. Go to the VPC dashboard again, click on the internet gateway. Everything will be on the left hand side. Create the internet gateway button, provide the name for the internet gateway button, create. That's all. And then we need to attach the internet gateway to the our required VPC, and click attach to the VPC. That's all. It will attach. Now associate the subnets within the route tables. Now we need to associate the subnets in my route table, right? That's the final step. Finally, associate the subnets that need internet access within the route table. That includes the default route pointing to the internet gateway. Once you have completed these steps, your subnet will be properly configured with the associated route table, and you will have option to provide the internet access to the specific subnet using the internet gateway and custom routes. We need to keep remember one thing: adjust the security group settings as needed to control the traffic and from in the instances within the subnet. So what we did is, so far we created the VPC. First, we created the VPC. Within the VPC, we created the subnet, and we attached it into the VPC. And then we are creating the route table that we attached into the VPC. And then we are creating the route, and that we are attaching into the route table. And we are creating the internet gateway that we are attaching into the route, and then we are attaching into the route as well as no, and then we are attaching into the VPC, and then we are creating the security group that we are attaching into the VPC, and we are creating the NACL that we are attaching into the subnets. That's all. Okay. Now we are going to discuss about the security group and then NACL. Okay, what is that? Controlling the inbound and then outbound traffic. So far we created the in traffic routing table that has a routes, right? Each routes we need to be controlled. Either it could be the inbound traffic, or it could be the outbound traffic. We will see one by one. Security groups and the network access control list are two important AWS features used for controlling the inbound and then outbound traffic in an AWS Amazon Virtual Private Cloud. They provide the different level of control and then serve different purpose in enhancing the security of your cloud infrastructure. Security group. Okay. So you understood, right? We are going to controlling the inbound and then outbound traffic. That's all. So security groups. The security groups are associated with the EC2 instance, Elastic Load Balancer, and other AWS resources. Each resources can have one or more security group. Security group are stateful. Okay, stateful. Yes means stateful. Okay, which means that if you allow the outbound traffic from your instances, the response traffic for the inbound connection is automatically enabled. Outbound traffic is enabled means inbound traffic will be enabled automatically. That's all. Rules. What is the rule? We will see. Security group rules based security group are rule based and primarily focus on allowing or denying the traffic based on the port number. Okay, source destination IP address or other security. So port number, security IP addresses we need to remember. And SG means it's a uh, security, yeah. So security group means what we need to keep remember is outbound traffic automatically allowed. Okay, allow outbound traffic. Response inbound traffic will also allow. Okay, that is the important point. Okay, and what is the default behavior? By default, inbound traffic is denied unless you explicitly allow it. By default, all outbound traffic is allowed unless you explicitly deny it. Okay. So security group means outbound will be enabled by default, inbound will be disabled, denied by default. Okay. Evaluating the rules. Rules are evaluated strict stateful manner. If there is an inbound rule that allow traffic from IP address, then the corresponding outbound response traffic is automatically allowed. Okay. This is stateful, outbound, and then inbound. Okay, we need to keep remember. Use case. SG are suitable for controlling the traffic at instance level, are commonly used for application specific security rule. Application specific means in we will go to the SG. They are well suited for scenarios where you need fine grained control over the network traffic between the instances and other AWS resources actually. Okay. What is NACL? What is the scope of NACL? We will see. So the NACL operate at the subnet level. The SG operates at instance level. The NACL operate at subnet level. NACL, okay, subnet. Each subnet in the VPC can associated with one NACL at a time. Okay, at least one NACL will be there. NACL are stateless. SG is stateful. NACL means it is a stateless. Okay. Okay, NaCl, L, and then less. SG, yes, so stateful. Okay, which means that if you allow inbound traffic, you must also explicitly allow the corresponding outbound traffic. There we saw that outbound traffic by default, so inbound rules also allowed actually. Here, inbound is allowed. Inbound is allowed, so the outbound will be allowed by default. That's what they are saying. We'll see that. NaCl use numbered rules, okay, that are evaluated in the ascending order. But here what we see is the rule is primary focuses on port number and then IP addresses. But here the rule is it is a ascending order. So NaCl will have a priority number 1, 2, 3. Based on that, it is allowing the I mean the rules will be ordered actually. Control traffic based on the source, destination, IP addresses, and then port ranges. You can create inbound, outbound rules to specify the type of the traffic that are allowed or denied. Okay. What is the default behavior? By default, in here we saw that I, right? So all the inbound rules and then outbound rules is denied unless you explicitly allow it by adding the rules to the NaCl. So here the evaluating rules will be based on the rule number. Here the evaluation strictly based on the stateful manner. Here based on the a number, rule number. The first rule that matches the packet's attributes, is applied, and subsequent rules are not evaluated. Here stateful manner, if there is any an inbound rule that allows the traffic from the IP address, the corresponding outbound responses traffic is allowed actually. But here, if one of the rule is matched or matches the packet's attributes, then that's all. The further rule will not be evaluated. Use cases. NACL are suitable for controlling the traffic at the subnet level and are often used for broader network level security control. They can used to enforce the stricter network level control that apply to allow all the resources within the network actually. Okay, choosing between the SG and then NACL, which one is, how to choose that, right? That's a good question. So, when securing your AWS infrastructure, you typically use both SG and then NACL together to layered security. Start with the SG to control the traffic in the instance or the resource level, then use the NACL for broader network level control. It is important to carefully design your security group and then NACL to balance the security networks within the operational needs while ensuring that the traffic is allowed where necessary and blocked where it is not required for your applications to function securely. So, application level control, go for SG. Completed. Next, we need to think about the network level. Yes, come to the NACL network, or we can say it is a subnet level, right? Yeah. So the infrastructure required definitely two control security layer, SG and then NACL. Okay. Now we are going to look at the NACL, how to create the NACL rules in the AWS. Okay. Okay. So explain how to set up the NACL rules in the AWS console. I'm going to answer that. Setting up a network access control list rules in the AWS management console involves configuring the inbound and then outbound rules to control the traffic allowed or the denied at the subnet level within your Amazon Virtual Private Cloud. Here is a step-by-step guide how to set up a NACL rules in the AWS console. So we are going to set up a NACL console, NACL control. NACL means definitely we need to keep in our mind inbound, outbound traffic rule, subnet, subnet, and then inbound is taking the priority here. Okay, if the inbound is default, and then outbound will enable. If the inbound enabled, outbound will be enabled. And here the rule numbers will be evaluated, and then if anything is matched, then the further rule will not be executed. All these we need to remember. Okay. Now we are going to sign in into the AWS console and then with the specific account and then open the VPC dashboard from the AWS management console. Navigate to the server services drop down menu and select VPC under the networking and then content delivery section. This will take you to the VPC dashboard. Select the network ACL. In the VPC dashboard, click the network ACL. In the navigation pane on the left, choose the NACL to configure. You will see a list of NACL in your account. Select the NACL that you want to configure or create a new one by clicking the Create Network NACL button. Configure the inbound rules. To configure inbound rules, click the inbound rules tab for selected NACL. Click the Edit Inbound Rules button to add or modify the rules. Click Add Rule to create the new rule. Define the rule properties, including the rule number, which determines the rules evaluation order, source IP or CADR range, port range, action. Click Save Rules to apply the changes. Configure the outbound rule. To configure the outbound rules, click the Outbound Rules tab for the selected NACL. Click Edit Outbound Rules button to add or modify the rules. Add rules, create the new rule, define the rules properties, including the rule number, and then destination IP add or the CADR range, port range, and then action, either allow or the deny. Click Save Rules to apply the changes. Now, we can view the rules and the rule evaluation. After configuring the rules, you can view them in the inbound rules and then outbound rules tab. Rules are evaluated in the ascending order, not a descending order, ascending order. And the first rule that matches the packet's attributes is applied and the subsequent rule are not evaluated. Associating the NACL within the subnet. Once the NACL is defined, we need to associate it with the subnet. To make the NACL effective for the subnet, you must associate the NACL with the subnet. Click the subnet association tab for the change for the selected NACL. Click edit subnet association to associate the NACL within one or more subnets, and then we will save the changes after changing the NACL rules and then associate the NACL with the subnet. Make sure to save the changes. Now we are going to test and then monitoring it. After setting up the NACL rules, it is essential to thoroughly test your network connectivity to ensure the traffic behaves as expected. You can also monitor the NACL traffic and rule hits using the VPC flow logs or other monitoring tools. Remember that NACL are stateless NACL or stateless. So if you allow inbound traffic, you must also explicitly allow the corresponding outbound response traffic. Carefully design the NACL rules to meet your security and then requirement while maintaining the necessary connectivity for your applications and resources. So what we did so far, we logged into the console, we went to the VPC, we created the ACL, and then we choose the NACL configuration, and then we created the inbound rule, and then we specified that what is the rule number and what is the CADR range, and then what is the port, and then what is the action allow or deny, and then we saved the rules, and then we created the outbound rule there where we defined that what is the destination IP, and then what is the CADR range, and what is the port range, and what is the allow or delay that we specified. After that, we saved the changes. After that, we viewed the rules and then evaluation. The rules are evaluated in the ascending order, and then the matches the once if it is matches the attributes, then subsequent rules will not be evaluated. And then we choose that associating the NACL with the subnet because NACL is subnet level, SGE is application level. That's the primary difference. And then we attach that NACL with the subnet. Once we save associated that, we saved the changes, and then to testing and then monitoring, we are using that VPC flow logs monitoring tool to check the flow logs to monitoring the traffic, and remember that the NACL are stateless. Keep remember inbound traffic. If you allow inbound traffic, you must explicitly allow the outbound traffic to be response traffic. That's all. Now seventh one. Okay. How to connect your AWS VPC to internet using an internet gateway. So now I want to know I created the subnet, right? And I want to talk to outside of the world through the internet. How I will do it through the we have a feature called as internet gateway that enables us to talk to the outside of the world. We'll see. To connect your Amazon Virtual Private Cloud to the internet using the internet gateway in the AWS, you need to follow these steps actually. Before proceeding, ensure that you have already created the VPC and then subnets. This is the prerequisites. Okay. Okay, now what we are going to do is, we will go to the console, AWS Management Console, sign in into your AWS account. Then second step is, open the VPC dashboard from the AWS Management Console, navigate to the Services drop-down menu, and select VPC under the Networking and then Content Delivery section. This will take you to the VPC dashboard, and then select the Internet Gateway. VPC dashboard, click Internet Gateway in the navigation pane on the left. Create the internet gateway if not already created. Just to create internet gateway, that's all. It will give the name, it will create it. Attach that internet gateway to your VPC. Okay, that's important. The subnet in which you are going to add that corresponding VPC, we need to be attached into that, right? And then select the internet gateway that you created. Click the action button and then choose attach the VPC, and then select the VPC that you want to attach the internet gateway and confirm the attachment, and then update the route tables. Now the route table coming into the picture. Okay, now that you attach the internet gateway to your VPC, you need to update the route table for your subnets to direct traffic destinated for the internet to internet gateway. In the VPC dashboard, go to the route table in the left navigation pane, update the main route table. By default, the main route table associated with the VPC routes traffic within the VPC but does not traffic to the internet gateway. To enable the internet access for your subnets, you can associate the main route table within your public subnet, or create the custom route table for your public subnet. Now what we will do is we will select the route table you want to update, and then click the routes, and then click on the edit route button, and add the routes actually. Add a route within the destination from the CIDR 0 to GIS, IPv4 and IPv6. Specify the internet gateway as the target. That's all. And then we are going to now save the route table changes. If you created the custom route table, your public subnet associate those subnet with the respective custom route tables, ensures each public subnet is associated with the route table that has a route to the internet gateway. So our ultimate aim is public subnet need to talk to internet, right? So what we need to do is each public subnet is we need to be associated with the route table. That's the point. Testing, how we are going to testing it now. We done the association, right? Testing, launch an ec2 instance in one of your public subnet. We need to launch one ec2 instance in one of the public subnet and assign it elastic ip or a public ip address. This instance should be now how internet connectivity, so we can test it whether that has internet connectivity or not. Okay, now we successfully tested it. Okay, once again, what we did here is, we created the we went to the AWS console, we opened the dashboard, and then we selected the internet gateway, and we created the internet gateway. We attached that internet gateway with the VPC. Once we attach the internet gateway with the VPC, we update the route tables and then we are updating the route table, and then we are updating the route table. Um with the CIDR range, add the internet gateway to the target, and then associate the subnets with the route table that has a route to the internet gateway. We need to see source and destination. Both should be there in the route table. That's the biggest thing, and we need to test it whether the source and the destination is invoking or not, right? We need to launch the EC2 instance in the public subnet and then test it there by elastic ip. So this way we can able to test it actually. And then security group rules optional. Ensure that your security group rules allow outbound traffic from your instances if you want them to access the internet. So this is important. See, if my outbound talk to internet means, then what we need to do is our security group rules allow the traffic from your instances you want them to access to the internet. By default, security groups allow the outbound traffic. Okay, with these steps completed, your VPC now connected to the internet through the internet gateway. Instances in the public subnet can send and receive the traffic to and from the internet, while instances in private subnet remain private and inaccessible from the internet unless you configure the network address translation or the VPN. So my public subnet can talk to the internet through the IG, but my private network cannot able to talk to the internet gateway. Instead, we have a feature called as NAT, network address translation, or VPN direct connect. Okay, now what we are going to discuss is, optional for connecting to an on-premises data center. How to, connect with an on-premises data center. That's what our next step. For that, what we are going to use is VPN or the direct connect. Connecting on your on-premises data center to Amazon Web Services can be achieved through two primary methods. One is VPN, Virtual Private Network. The another one is AWS Direct Connect. These two methods enable secure private, and reliable communication between on your on-premises network and your AWS virtual private cloud. Here is an overview of both options. Okay, first overview. VPN. Okay, VPN is a secure and then cost-effective method for establishing encrypted connection over the public internet between your on-premises network and AWS VPC. AWS VPN solution include AWS site-to-site VPN and then AWS client VPN. What is AWS site-to-site VPN? This option enables you to create the VPN connection between your on-premises data center and your VPC. Key feature include IPsec based encryption, redundancy for high availability, and support for dynamic and then static routing. Site-to-site VPN allow you to extend your on-premises network into your VPC securely. AWS Client VPN. AWS Client VPN is used for providing secure remote access to your VPC for individual users or client. It's particularly useful for remote worker or accessing resources securely from different locations. Client VPN can be used an additional to site VPN for comprehensive remote access. What is the pros and then cons? VPN is relatively easy to set up and then cost effective as it uses existing internet connections. It provides encryption and then security for data in the transit, suitable for hybrid cloud architectures and then remote access scenarios. Cons. VPN connection rely on internet bandwidth and may not provide consistent performance on or low latency, specifically for data intensive workloads. VPN might not be ideal for large scale, missions critical, or latency sensitive applications. So this is the negative of the VPN actually, right? So it will not support the latency actually, right? Low latency, and VPN not be ideal for the large scale actually. So so this is very big negative actually. But it is a cost effective, right? Cost effective, and it provides the encryption and then security for the data transit actually. So what they are saying is we have a two way of to connect to the my on-premises data center. One is VPN. The second one is AWS Direct Connect. The VPN has a two type. One is AWS site-to-site VPN. The another one is AWS client VPN. The AWS site-to-site VPN connection between on-premises data center and a VPC. But VPN is used for providing the secure remote VPC for individual users or the clients actually. This is individual users. This is data center and then VPC actually. The negative is it will not support the low latency. That's the biggest negative. Okay. Positive is it is the cost effective and then no data encrypt and then security features are there. Okay. We'll see about the AWS Direct Connect. AWS Direct Connect provides the dedicated private network connection between your on-premises data center and AWS by bypassing the public internet. It offers an enhanced reliability, lower latency, high throughput compared to the VPN. Okay, it has a demerit as well. We will see in the below. So direct connection, connect location. AWS Direct Connect is available in various regions. Um, a- okay, you can choose to connect to AWS through a direct connect locations or through a partner network. Connection types, dedicated connection type. These are dedicated physical connection between your data center and AWS. Hosted connections. These are provided by the AWS direct connect partners and offer flexible in terms of port speed and then terms. Okay, what is the primary advantages of the AWS Direct Connect? Provide dedicated private predictable network connections with consistency performance suitable for data intensive workloads, larger large data transfer, and latency sensitive applications. Enhance network security by bypassing the public internet actually. Okay. So it is bypassing the public internet. Okay. The negative of the direct connect is mm, direct connect can more expensive than the VPC. That is the biggest negative. Okay, as it involves dedicated circuits or cross connect fees. So requires a physical infrastructure and then coordinate with the co-locations provides or direct connect partners. Choosing between VPC and then direct connect, which one you will choose, right? Choose VPN when the cost effectiveness, simplicity, and secure remote connect access are primary consideration. Choose the VPN. Okay. Choose direct connect when you require high bandwidth, low latency, guaranteed performance for mission critical workloads or larger scale data transfer. By the time, what we will do, we will go with the data direct connect actually. Okay. Many organizations opt for a combination of both VPN and then direct connect to meet the different connectivity need within a hybrid cloud architecture. The choice ultimately depends on your specific use cases, budget, and then performance requirement. So cost effectiveness, when we think about the cost, we need to go for the VPN. If the When we consider that workload, mission critical, large scale data transfer, go to the direct connect. That's all. Okay. Describe VPC pairing and its use cases. We will see about what is the VPC pairing and what is the primary advantages of it and the key characteristics and so on. Okay. Amazon Virtual Private Cloud pairing is a network feature provided by Amazon Web Services that allows you to connect two VPCs to each other. So VPC pairing means each other. Two VPCs will connect each other, or multiple VPCs connect each other actually. So that's the plan. Ensure secure and then private communication between the resources in different VPCs as if they were on the same network. But the condition here is the two VPCs should be on the same network actually. VPC pairing facilitates inter-VPC communication without need for virtual private connection or direct connect. Here is an overview of VPC pairing and its common use cases. Key characteristics of VPC pairing. First one, private connectivity. The second one, transitive pairing. Third one, IP addressing. Fourth one, security. And then these are the four. Okay. Common use cases. Okay. VPC connectivity. VPC pairing establishes a private connectivity, meaning that data exchange between paired VPC does not traverse the public internet. So the VPC, the paired VPCs, no need to go to the public internet actually. Transitive pairing. VPC pairing can be a transitive, allowing multiple VPCs to be interconnected through hub and then spoke model where a central VPC server as a hub for routing the traffic between multiple VPCs. So one VPC that will be act as a hub that will route the traffic between multiple VPCs actually. Okay. IP addressing. Each VPC retain own its IP address space and the CADR block of the peered VPC should not be overlapped. So this is the primary condition. The IP should not be overlapped actually in the CADR block. What is the security? VPC pairing does not change the security boundary of VPC. You still need to configure the security group and the network ACS, network ACLs to control the traffic between the resources. Okay, VPC, it will not cross the boundary, but still we need to set the security group as well as the network ACL. Okay, NACL for subnet level, SG for application level. Okay, common use cases for the VPC pairing. One is multi-threading application, second one is isolated environments, third one is shared services, fourth one is cross-account access, fifth one disaster recovery, sixth one data transfer, the seventh one global reach. And the eighth one is, considerations for the VPC pairing. We will see that. Okay, what is the multi-tier applications? VPC pairing is available for multi-tiered applications separate across multiple VPCs. For example, you can have a web tier in one VPC and the database in another tier VPC, with VPC pairing enabling the secure communication between them actually. So we will create a two VPC, one with one for my instances will be there, the another one database layer will be there, and then it will each will communicate with the secure communication actually. And isolated environment. VPC pairing, allows you to create isolated environments for development, testing, staging, and then production. Each environment can reside in a separate VPC while maintaining the secure connectivity. So we created the multi-architecture, right? My instance and then database will be in one VPC, and I will keep multiple VPC, and that will be for one environment, that is for develop environment. Then I will create another environment that has its own VPC, and that has its own resources actually. And I'll create one more environment for production, and that will be connected to my production related resources actually. So I can able to isolate individual environment. That's why we are calling this scenario as isolated environments. And now shared services. Shared services means multiple application will share one resource. That's why you can centralize the shared services, authentication, logging, monitoring in a dedicated VPC and pair it with another VPCs to provide those services, multiple applications of the VPCs actually. And then cross account access. VPC pairing can establish the established between VPC in different accounts, enabling a secure communication between the resources owned by the different organization or teams. So cross account access, right? So what will happen is different accounts will be different communication between the resources will be in the cross account access actually. That we can able to enable it. Disaster recovery. VPC pairing can used for disaster recovery scenarios. You can replicate the data and then resource between primary VPC and then secondary VPC, ensuring the data redundancy, and then it creates high availability. That's all. The disaster recovery. Data transfer. If you have data stored in one VPC that needs to be associated accessed by applications in another VPC, VPC pairing allows you to transfer the data efficiently without public internet exposure. Okay, without public internet exposure, we can able to transfer the data. And global reach. VPC pairing work across AWS region, allowing you to establish the pair connection between VPC in the different region, support global deployments. We can keep the VPCs in a different regions, and then we can be able to make it, communicate each other, which different region, different group, sorry, different accounts. We can keep it as keep this in, and then we can able to interconnect each other. Okay. What are all the considerations for the VPC pairing? Ensure that there is no overlapping IP address space between the VPCs. Pairing connections are not transitive by default, meaning that if VPC A is paired with VPC B and VPC B is paired with VPC C, VPC A and then VPC C are not automatically paired. You can enable the transitive pairing by configuring route tables appropriately. VPC pairing does not support transitive network address translation in NAT. Okay, that is for talk to internet. Okay, you need to set up a NAT gateway or instance for resources in the private subnet to access the internet via the VPC owned internet gateway. So VPC pairing is powerful networking feature that enhance the flexibility, scalability, and secure of AWS deployments by enabling the seamless communication between the VPCs. It is a valuable tool for architecting complex multi-thread and distributed application in the cloud. Okay, so what we saw so far is how to connect the how to create the VPC pairing, right? What are all the use cases? Best use cases this multi-tiered application, isolated environment, shared services, cross-account access, disaster recovery, data transfer, global reach. These are all the scenarios. Okay. Show how to set up the VPC pairing in the AWS console. We are going to see, create a VPC pairing in the AWS console. Setting up the VPC pairing in the AWS console involves configure the pairing connection between two virtual private cloud. Here is a step-by-step guide actually. Note, ensure that you have a VPC ID of both VPC you wanted to pair. So first we need to make this is the prerequisite. We should be created the VPC prior actually. VPC are in the same AWS account or have a necessary permission if they belong to the different account. Okay, if the VPC is sitting on the different account, then we need a necessary permission need to be created in the IAM role. Okay, IAM access. Okay, sign in to the AWS console. Go to the AWS management console, sign in to your AWS account, open the VPC dashboard. From the AWS management console, navigate to the services drop-down menu and select the VPC under the network and then content delivery selection. This will take you to the VPC dashboard. Select the peering connection. In the VPC dashboard, click the peering connection in the navigation panel on the left. Create the peering connection. Create the peering connection between button and then configure the peering connection. In the creating the pairing connection wizard, provide the following information. Give your pairing connection a descriptive name. Request your VPC. Select the VPC that initiate the initiate the pairing connection. Accept VPC, specify the ID of the VPC that will accept the pairing request, allow DNS resolution from the requester VPC to the acceptor VPC, requester VPC to the acceptor VPC. Okay, two VPCs. One is requester, the another one is acceptor. Creating the pairing connection, create after creating the pairing connection detail, click the create pairing connection button. The pairing connection will be pending accept state. It establish the connection. Go to the AWS management console of the pairing acceptor VPC account. So if the VPC is sitting on the another account, then we go there. That is the acceptor VPC, right? In that acceptor VPC console, navigate to the pairing connection, select the pending pairing connection, add the action button, accept the request, and then create the route tables. By default, VPC pairing connection do not modify the route tables of paired VPCs. If needed, you can update the route tables in the VPC to specify how traffic should be routed to the paired VPC. Now, how to test the validation. So, requester will send the request and then the acceptor need to be accepted actually. Testing and then validation. After the pairing connection is established, you can launch the resources in the VPC and test connectivity between them. Ensure that security group rules and network control list allow the necessary traffic. Remove pairing connection. If no longer needed pairing connection, you can delete it by selecting in the pairing connections section and click the action button. Then select delete pairing connection. VPC pairing allows secure and then private communication between VPCs in your AWS environment. It is a powerful feature for building the complex multi-tiered distributed application while maintaining the network isolation and then security. So if no longer needed, right, we need to delete it. That's the primary point. So for testing and then validation, just we need to go and launch the resources within the VPC and then try to access it, and then ensure we need to know set the security group and then NACL. That's an important aspect actually. Now, ninth one. Okay. Share some best practices for designing and then managing the AWS VPCs. Designing and managing Amazon Virtual Private Cloud effectively is crucial for building a secure, scalable, and then high performance cloud infrastructure in the AWS. Here are some best practices to consider when designing and managing the VPCs. We will see one by one. First, plan your IP addressing carefully. Design your IP address range, CIDR block, with the future growth in mind. Avoid overlapping CIDR block between VPCs. Consider the IPv6 in addition to IPv4 to future proof your VPCs. Document your IPC address allocations to ensure efficient use. Okay. Use multiple availability zones. Deploy your resources across availability zones for high availability and fault tolerance. Okay. We need, high availability and fault tolerance. Configure the public and then private subnets in the each AZ to distribute the workload actually. Isolate the resources with the subnets actually. Organize your VPC resources into subnets based on security and then functional requirements. Use public subnet for resources that need internet access, and then private subnets for those that should remain isolated. So public means we will connect with an internet. Private means it should be remain the isolated actually. Okay. Leverage the route table effectively. So create the custom route table for the subnet to control the traffic routing. Use route tables to route the traffic between the VPC, VPN, direct connect, and then internet gateway. Okay. So definitely we need a route table. So we need to control the traffic routing actually, and then implement the secure controls. Use secure controls, no, control for no inbound and then outbound traffic. For instance, use network control less NACL to connect the traffic at the subnet level. Okay, and apply the principle of least privilege when defining the security rules. Actually, use bastion host and the jump boxes. Deploy the based and host or the jump boxes in the public subnet to provide the secure access to resource in the private subnet. Securely manage and restrict the access to the jump host actually. Monitor and then log traffic. Enable your VPC flow logs to capture the network traffic for analysis and then security monitoring. Consider using AWS services like Amazon Cloud Watch for real-time monitoring and then alert actually. And then secure data transfer. Use encryption in the transit, TLS and then SSL at rest. I mean, we are going to KMS, right? So that we need to use it actually. Plan for scalability. Design VPCs to scalable by following AWS best practices. Use auto scaling group for horizontal scalability of application instances, and we need to add the disaster recovery and then backup. Implement the backup and the disaster recovery strategies to ensure the business continuity. You use AWS services like S3 for data backups, and then automate provisioning and then management. Leverage AWS CloudFormation or infrastructure as code IAC tool like AWS CDK to automate VPC provisioning and then configuration. Use Lambda for serverless automation task. Keep documentation up to date. Maintain detailed documentation of your VPC configuration, including the diagram and then IP address as assessments. Document the purpose and then expected behavior of each subnet and the security group. Regularly review and then audit. Conduct the periodic security audits and then compliance check to identify and remediate vulnerabilities. Keep your VPC configuration aligned with best practices and industry standard. Stay informed. Okay, stay up to date with AWS announcements, new features, security best practices related to VPCs. Join AWS forums and communicate to learn from others and ask questions. Actually, so this is stay informed. Actually, use AWS well architected framework. Allow the AWS well architected framework to ensure your VPC designs are aligned with the best practices, optimized for cost, performance, security, reliability, and operational excellence. By following these best practices, you can design, manage, and then AWS VPCs that are secure, efficient, and capable of meeting your business and then technical requirement effectively. So, what are the best practices? Plan your IP address carefully, multiple availability zones, isolated resources with subnet, leverage the route tables effectively, implement the security control NACL, and then host and then jump boxes, and then monitor and then log traffic, secure data transfer, plan scalability, disaster recovery backup, automate provisioning and then management, keep documentation, regularly review and then audit, stay informed and then well architected framework. Okay, So, when designing and managing the Amazon Virtual Private Cloud, it's crucial to balance the security, scalability, and the cost optimization to ensure a well-architected and efficient cloud infrastructure. Here are considerations for each of these aspects in the VPC design. First, security consideration. Okay. Network segmentation. Divide your VPC into private and then public subnet to separate the resources that require internet access from those that should remain isolated. As much as possible, we need to isolate it. Security groups. Use security group to control the inbound and then outbound traffic. Whatever we saw earlier, right? The same points actually. Follow the principle of least privilege and regularly review and update the security group rules actually, and then add in the security group for application level, network access for subnet level. Implement the NACL at the subnet level to control the traffic. NACL acts as additional layer of the security, can provide the defense in depth actually. Now, data encryption. Enable the encryption for data in the transit, TLS, and then SSL certificate, SSL, data at rest, AWS management key. The same point. Identify and then access resources. Basically, IAM they are talk about. Best practices to manage the AWS resources carefully, actually. VPC flow logs. Enable the VPC flow logs to capture and monitor the network traffic. And then this we saw that already jump boxes. And then this is important. DDO mitigation. Okay, implement AWS Shield and then AWS WAF to protect your VPC against distributed denial of services attack and web application vulnerabilities. So we need to add the AWS Shield and then AWS WAF actually. We will see that what is AWS Shield and then what is WAF in detail later sometime. And then availability zones. Deploy resources across multiple zones for a high availability. Design your VPC to resilient to failure in any single zones actually. Elastic Load Balancer (ELB) to distribute the traffic across multiple instances, ensure the scalability and then fault tolerance. Auto scaling. Set up your auto scaling groups to automatically adjust the number of instances based on the traffic pattern. Ensures that you have a right capacity at all time. And then Amazon RDS read replicas. If you are using the RDS, consider the read replicas to distribute the data, read traffic, and improve the scalability. Use Amazon Cloud Front for content delivery to distribute the content to users globally and then reduce latency. Horizontal scalability. Design your application horizontal scalability allow you to add or remove the instances as needed to handle the varying workloads actually. Cost optimization consideration. So far, what we checked is, security consideration. These are all the security consideration. Let's see the cost optimization. Resource tagging. Tag your resources with meaningful label to track the cost effectively. Use AWS Cost Explorer and AWS Cost and then usage report for cost visibility. And then reserved instances. Purchase reserved instances for predict the workloads to save instances cost. Analyze the usage pattern to select the right reserves instances type actually. Spot instances. Use the spot instances for the critical workload that handle the interruptions. Spot instances can significantly reduce the compute cost actually. And then resource cleanup actually implement automated resources cleanup scripts or use services like the AWS Lambda to terminate or the stop unused instances and resources actually. Right sizing. Regularly review resource utilization and adjust instance type or size to match the actual workload requirement. Use AWS trusted advisor for recommendations. Cost monitoring and then alerts. Set up the cost monitoring and then billing alerts to be notified unexpected cost increases or usage spikes actually. Reserved capacity planning. Plan reserved capacity purchases based on the historical usage trends and future workload exceptions. Data lifecycle management. Implement the data lifecycle policies for store services like Amazon S3 to control the storage cost actually. Use AWS cost optimization tool, leverage the AWS cost explorer, AWS trusted advisor, AWS cost anomaly detection to identify the cost saving opportunities and monitoring expenses. Balancing security, scalability, and cost optimization in your AWS VPC design requires careful planning, ongoing monitoring, and adjust to the ensure infrastructure meets both technical and then budgetary control. Okay, so we saw that two things here: security consideration, and the other one is cost consideration. For the security consideration, network segmentation, isolation, security groups, inbound, outbound traffic, and then network ACL, subnet level control traffic, data encryption, KMS, and then identity access management, and then VPC flow logs to capture and then monitoring the network traffic, and then jump box for public subnet to access the resources in the private subnet securely, and then DDS mitigation, AWS Shield, and then WAF protection, scalability consideration, availability zone, and then elastic load balancer, auto scaling automatically adjusts the number of instances in the traffic rule, RDs read replicas to distribute the database, read traffic, and then improve the scalability. Content delivery, we will go CloudFront, and then horizontal scaling, allowing you to add or remove the instances needed to the handle various workload, and cost optimization consideration, resource tagging, track the cost effectively, and then reserved instances, analyze usage pattern to select the right instances type, reserved instances type. Spot instances can handle interruptions, reduce the compute cost. Resource cleanup, terminate or stop unused instances and then resources. Right sizing, review the resource utilization, use the AWS trusted advisor for the recommendations. And cost monitoring alerts, unexpected cost increases or usage spike, we can avoid it. Reserved capacity planning, historical usage trends and then future workloads. This plan will be helpful. And then data lifecycle management, storage services like we can use S3 bucket, use AWS cost optimization, AWS cost explorer, trusted advisor, cost anomaly detection. So cost optimization consideration, scalability option consideration, security consideration. That's wrap up our exploration of VPC. If you are looking to select a career in the cloud computing, AWS certification is a fantastic starting point. Thank you for watching. If you found this video helpful, please do not forget to like, share, subscribe for more tech related content. If you have any more questions or topic you would like us to cover in the future videos, please feel free to leave them in the comments below. Best of luck on your AWS certification journey, and I look forward to see you in next video. Thank you.